Good morning, everyone. I'm Narmatha, Assistant Professor, Department of Cybersecurity, working in Dr. S.N.S. Rajlakshmi College of Arts and Science. In today's lecture, we are going to discuss about operations on a process. So, we have several operations on a process: create, destroy a process, suspend, resume a process, change a process priority, block, wake up a process, dispatch a process, inter-process communication. So, let's see one by one. So first, operations on a process. So we have several operations. First one is create a process, destroy a process, suspend a process, resume a process, change a process priority, block a process, wake up a process, dispatch a process, enable a process to communicate with another process. Creating a process. It involves many operations including name the process, insert it in the system's known process list, determining the process initial priority, create the process control block, allocating the process initial resources. Parent process create children process, which in turn create other processes forming a tree of process. Generally, process is identified and managed via process identifier. Resource sharing operations and execution options will be there to perform different kinds of structures between parents and child. So this tree structure is represented here. So parent node and child nodes are represented in this tree structure. Process creation. Address space, child duplicate of a parent, child has a program loaded into it. So in Unix example, we are having two functions, fork and execution. So fork, what it does means it creates a new process, and execute, it used to uh, after a fork to replace the process memory space with a new program. So diagram is represented. Process termination. Process executes last statement and then asks the operation system to delete it using the exit system call. Return status data from child to parent. Process resources are deallocated by operating system. So parent may terminate the execution of children process using abort system call. So child has executed allocated resources. Task assigned to child is no longer required. The parent is exiting and the operating system does not allow a child to continue if it is parent terminated. Some OS do not allow child to exist if its parent has terminated. If a process terminates, then all its children must also be terminated. Cascading termination, all children, grandchildren, etc. are terminated. The termination is initiated by the operating system. The parent process may wait for termination of a child process by using the wait system call. The call returns status information and the process ID of the terminated process. So PID is equals wait of status. So it represents the status of a particular process. If no parent waiting, process is a zombie. If parent terminated without invoking wait, process is an orphan. Suspending a process. A suspended process cannot proceed until another process resumes it. Suspension normally lasts only a brief period of time. They are often performed by the system to remove certain processes temporarily to reduce the system load during a peak loading system. For long-term suspension, the process resources should be freed. The decision about freeing resources depends very much on the nature of each resource. Primary memory should be freed immediately when a process is suspended. A tape drive may be retained by a process suspended only briefly but should release by a process suspended for a lengthy or indefinite period. Modifying, resuming a process involves restarting it from the point at which it was suspended. Changing the priority of a process normally involves nothing more than modifying the priority value in the process. From this lecture, you can understand about, I think you understood about the concept of operations on the process states. Thank you.